Hello everyone, I'm going to solve the part 4 problems. So let's start with problem number 18. So problem number 18 says that it's given a matrix and its power entries of its nth power is given by an, bn, cn, dn, that sequence, and then we have to find out the limit of an by bn. So it's basically a computational problem. So if you write down 1110 times 1110, you will get 2111. Similarly, if you do the uh, third power, then you will have 3221. Similarly, if you do the fourth power, you will have 3221 1110. Then we will have 5332. Now you can see, if you observe the entries of this behavior, then a power n, entries of a power n is given by an, bn, cn, dn, right? Then you can see that an is basically equal to an minus 1 plus bn minus 1, and bn is basically equal to an minus 1. Okay, then what will you have? An by bn is basically equal to an minus 1 plus bn minus 1 divided by an minus 1. It is basically 1 plus bn minus 1 divided by an minus 1. Now say limit n tends to infinity, an by bn equal to L. Okay, then this is same as limit n tends to infinity, an minus 1 divided by bn minus 1. That means L equal to 1 plus 1 by L, and L square equal to L plus 1. If you solve it, you will get the solution is said to be golden ratio. This is called golden ratio. You can search it in Google. It's a very important term. That's called golden ratio, because this sequence, that an equal to an minus 1 plus an minus 2, because bn minus 1 is basically same as an minus 2. This is a Fibonacci sequence. Fibonacci sequence. So the limit exists, and the limit is basically equal to something called 1.6 some value, which is called golden ratio. So that's why the correct answer will be none of the remaining three options. Okay, now come to problem number 19. It's given that we are considering all complex polynomials of degree at most 50 that satisfy the condition. Okay, so let's take polynomial to be degree 3 polynomial. Okay, say px equal to a0 plus a1x plus a2x square plus a3x cube. Then p of ix basically a0x a1 times ix minus a2x square minus a3 ix cube, and px and minus px equal to minus a0 minus a1x minus a2x square minus a3x cube. If I equate these two equation, say this is 1, this is 2, 1 equal to 2, then you will have a0 equal to minus a0. That means a0 is 0, a1 becomes also 0, a3 becomes also 0, but a2 can be anything, right? A2 can be anything, but a0, a1 and a3 becomes 0. Similarly, these will behave same if you do the degree 4, like when you are taking x to the power 4 and the coefficient of x to the power 4 behaves same like a0, coefficient of x to the 5 behaves same like a1, coefficient of x to the 6 behaves same like a2. Okay, So all then only A2, A6, A10, A14, this term will contribute in dimension because other coefficients become 0. Okay, and the given space is actually at most degree 50, right? Polynomial given space consists of the polynomial of degree at most 50. It is basically a 4k plus 2 term where k greater or equal to 0. So 4k plus 2 less than 50, this will imply k less equal to 12. So k starts with 0, 1 till 12. The possibilities of k is 13. Hence the dimension will be 13. Okay, so this is an easy problem and is also a jam level problem. Jam aspirant should seriously take this type of problem. Okay. Okay. Now I think okay. Now question number 20. Question number 20. So question number 20 is also a good problem. So it says that we are considering all real sequences and then it maps to a1 a2, this is sequence a1 by 10 plus a2 by 10 square and so on. Okay, so let a equal to the sequence this, okay, and b equal to this sequence. Subjectivity is clearly discarded because f is given s to r, where s is the set of all real sequence, right? It's given to r. So if you choose any real number, say 3, then you can see that it cannot have any pre-image because here all the terms a1 by 10, a2 by 10 square and a1, a2 all are either 0 or 1. That means it is strictly less equal to, I mean clearly less than equal to 1, the values, right? The sum in the right side. So it cannot take the value 3 or 4 or anything greater than 1. Hence it's clearly not surjective. Okay, it's clearly not surjective. But the issue is about the injectivity part. Okay, so let's assume that fa equal to fp, where a is a real sequence a1 a2 this and b is a real sequence b1 b2 this. Okay, then clearly ai by 10 to the I equal to 1 to infinity is equal to bi by 10 to the I equal to 1 to infinity. Now let k be the smallest positive integer such that ak not equal to bk. Smallest one. I'm assuming that the smallest one. Then since till k minus 1 term both are same, then I can write it as 10 to the I and I starts from k because already up to k minus 1 term they are same, and since the entire sum is same, so I can rewrite as and start from k, right? And it is given that ak not equal to bk and k be the smallest number, right? So without loss of generality, since AIs can take either 0 or 1, so without loss of generality I can assume that AK equal to 1 and BK equal to 0 because they are not equal. So if AK takes value 1, then BK will be 0. Then 1 by 10 power 10 to the K plus summation AI by 10 to the I equal to K plus 1 to infinity is same as summation BI by 10 power I equal to k plus 1 to infinity because bk is already 0. in the left hand side this is greater or equal to 1 by 10 to the k, and in the right hand side if all bi is equal to 1 for all I greater or equal to k plus 1. Okay, that means pi power 10 to the I equal to k plus 1 to infinity less than equal to 1 by 10 to the k plus 1 plus 1 by 10 to the k plus 2 and so on. Okay, that is same as 1 by 10 to the k plus 1 divided by 1 minus 1 by 10. It is same as 1 by 9 into 10 to the k. Okay, that means summation bi by 10 to the I equal to k plus 1 to infinity. This is less equal to 1 by 9 into 10 to the k, which is strictly less than 1 by 10 to the k. Which is strictly less than 1 by 10 to the k. And summation bi by 10 to the summation ai by 10 to the I equal to k to infinity, that is greater or equal to 1 by 10 to the k. Hence they cannot be equal. They cannot be equal. Hence ak equal to bk, that gives a contradiction, right? That means ak equal to bk for all k. Hence they have to be same. So clearly it is injective. Okay, clearly it is injective. Okay, so I'm going to solve problem number 8. It says that an equals limit n tends to infinity summation 1 by k square k equal to small n to capital N. Okay, and we have to find out what is the limit of n dot n. So claim, so this one is a non-trivial problem. I already told that claim is basically a comparison. Okay, so we are going to use some sandwich argument. So claim is integral small n to capital N plus 1 by x square dx is basically summation by k square k equals 1 into capital N less equals integral n minus 1 to capital N x square dx. So you can think this as statement 1, you can think this as statement 2, and then use induction on capital N. So since this integral starts from n plus 1, so you can start induction on n equal to n, then you can assume it for some I, then you can show that true for I plus 1 also. Okay, so then you can say that this holds actually. Then you can solve it directly. If you know this inequality, then you can directly solve. So from the first part you will get, since that is the integration, so if you integrate it, then you will get 1 by n minus 1 by capital N plus 1, that will be less than equal to summation k equal to n to capital N 1 by k square less equal to 1 by small n minus 1 by n. Then if you take both sides capital N tends to infinity, then you will have 1 by n less equal to an less equal to 1 by n minus 1. Then 1 less equal to n dot n less equal to n by n minus 1. Then again if you take limit n tends to infinity, if you take that, then you will have this limit less equal to 1. And by sandwich theorem, L has to be 1. That means limit n dot n has to be 1. So the actual problem of this actual thing of this problem is completely this inequality. So if you know this inequality, then you can solve, otherwise you can't solve. It's not a trivial problem. So I already told it's a difficult one. it is the difficult. It's one of the difficult problem. I think so. So if you have any easy solution and any other solution, you can comment. If it is better, then I will make another video to to get to know everyone that this is another solution which is good and easy. Okay.